Page 52, number 7, we're looking at logarithms of different bases. And we're looking at how we can change them into a common base 10. Okay, now some of these you can do with a calculator, and some of them you can do without a calculator. So, first idea, I'm going to do this a little bit differently than I usually do, is if you have a different base, you can put it in base 10 by using our change of base formula, which says we can do log 5 over log 8. Now this one is telling us that 10 to some power is 5 and 10 to some power is 8. Those aren't nice numbers, so you have to use a calculator for that. Okay? I'm actually going to do each one of these individually. So how would you write the next one? Log of what? 8 over log 5. Okay, again, on this one, you can't really do it without a calculator. Yucky numbers.
Are there any ones you can't do?
Yeah, the next one you can do without a calculator. Okay, and there's a couple ways. The first way is to do it the same thing we've been doing with the calculator. Log root 5 over log 5. That'll work. Now the key here, go ahead, Tom.
Would that be, you can't make that 5 to the 1/2, move the 1/2 to the front, because there's still the base 5, right?
No, you can do that. So I'm going to get to that idea. Actually, let's do that right now. So what Tom's saying is that we can go log base 5 of 5 to the 1/2 power. That works. We can move this 1/2 out in front. So we got 1/2 log base 5 of 5. And what would log base 5 of 5 be? 1. If you have these are equal, that's just saying 5 to what power gives you 5. So whenever these two are equal, it's just 1. So that would be 1/2 times 1, which is 1/2. Okay, another way you could do it is if you look at my previous little setup right here, this can put it into base 10 like we did. This is all base 10 right here. All these are base 10. But when we do this, we can actually put it into any base we want. Okay? So if I see that there's some commonality here between, there's a 5 here, there's a 5 here, maybe I should use base 5 instead. I can do that. I can just put a little 5 down here. And now, the denominator here, what's this equal to? 1. So that's just 1. Let's go, that's 1. And then I could basically do the same thing we just did with Tom here that said I could just take this and make it a 1/2 power, move it out in front. Log base 5 of 5 is 1. So it's 1/2 over 1, which is 1/2 again. So that will also work. Okay, so either way it's fine. On the non-calculator portion, expect to be able to, have to do things like that, where you're like, okay, if I can't use a calculator, that means that there must be some way to use the same base. All right, in D, could have log of 2.5 over log 1.005. I don't see a whole lot of nice things coming out of when you're logging decimals. It's possible. I mean, you could have a base that's a decimal. I mean, if I had like 0.5 and 0.25, I would know that 0.5 squared is 0.25, and I could probably use a different type of base. But this is not easy right away, so I would just use my calculator. And I think when you use a calculator, it shows right away that you can't You have to use a calculator. Okay, so when we do that one, our answer here is 183.716, rounded. Not a nice number. And if it's not a nice number, that probably says you can't do it without a calculator. You have to use a calculator. Okay. Usually when I get a number that's that big, I also make sure I check the initial problem and see if it makes sense. Because 1.005 to what power is 2.5 is going to be a pretty big number, since 1 squared is 1. So this squared is just barely bigger than 1. So in order to get that to 2.5, you have to use this huge power, which makes sense. All right, last one. Initially, what do you think? Do we need a calculator, or do we not? So we're seeing a 3 and a 9. What does that tell you? What base are we probably going to use? Base 3. So a couple ways you could do this one. You could just say 3 to what power gives me 1/9. That's how I would do this. I wouldn't use a change of base. We can, and I will, just to show you that that's what we can use. But that's telling me 3 to what power is 1/9. Now, I'm going to have the same base. So 9 is 3 to what power? 2.
I knew that.
So that's 1 over 3 squared. And how can I get that fraction out of there?
1 over 9.
Multiplied by 3 squared.
Well, don't think about multiplying it by 3 squared. Negative. If it's 1 over something to a power, it's the same as the negative power, right? So we can make that 3 to the negative 2. And now x equals negative 2. Okay? That's one way you could do it. Another way you could do it is you could say, okay, let's go our usual, or not our usual, but what we would be doing, log of 1/9 over log 3. With a calculator, I can keep it in base 10, and I should get negative 2. But without a calculator, I want to have to change it to a base that's going to be common and work with both of them. So I would use base 3. So I'd change this to base 3. Now the denominator is just 1. This equals 1. And then we have to figure out that 1/9 is 3 to the negative 2 power. And then move that in front. And then this cancels, and you just have negative 2 over 1. Cancels as in it's 1, and then you multiply. Questions there?